Hey guys, do do I sound sad? Yeah. Okay, yeah, I do sound sad, but I have a good reason to. Because I took Star's request for how strong Amy is. Ah! Okay, now see, unlike most power scalers who just want to do like universal scaling, all that jazz, I wanted to use math to figure out how strong Amy is. Because I'm special, bro. I'm a special boy. Wait. That sounds horrendous. Anyways, yeah. Yeah, this was a rough video to make. So, here's a rundown for you guys. This video took about 4 hours to calculate, actually, from 11 p.m. to 2 a.m. Okay, so now I'm going to calculate it based off of the fact that Amy has one of two heights. I'm using MatPat's height calculation for her, where she's 5'2" for my first one, because that's the one I prefer. I prefer be having like modern Sonic characters being 5'2". I don't know why. It just makes more sense. But I'm going to also use the official Sega version where she's 3'3". Now you could say Sega says she's 2'11", but I looked at the Sonic Dream Team height comparison and she's like a hair's breadth shorter than Sonic. She's really like, you can't say she's 2'11" and then have her just be like barely shorter than Sonic. And Sonic is 3'3". So yeah, she would be around 2 foot. No, she wouldn't even be being 2 foot. She'd be around 3'2.5" actually. Because as I just said, Sonic is 3'3" and she's barely shorter than him. So the 2'11" is dumb, even though it's official. But don't worry, I'm gonna put my number calculations at the end so that you know how strong she'd be if she was 2'11". So, okay. Better strap in. I'm so unfunny. Anyways, truthfully though, the numbers get ridiculous. Like, the shorter she is, the bigger the numbers. Because I'm calculating her weights. I'm calculating her weights, right? Like the weights on her arms and feet. So because of how that works, the shorter she is, the heavier they are, because of the metric I'm going to be using. Okay, so now I'm going to show you my method. Okay, so firstly, the difficult part was getting a picture of Amy that where she's standing straight is genuinely hard, as unlike Sonic, she's always striking a pose. Though in Sonic Adventure Director's Cut, she stands straight up in this one scene with her protecting E105 Gamma. I said that shit off memory, I forgot to write that in my script. Okay, so anyways, I used my IRL ruler to actually measure her from head to toes, and I got the number of her being 3.4 centimeters tall. So that is our metric. So your first formula is 3.4 centimeters is now equal to the desired height that you have Amy. For this one, she is 5'2", which is 62 inches. So 3.4 centimeters is equal to 62 inches. Now divide both sides by 3.4 to even it out. And so now we have that for every 1 centimeter on screen of Amy, she is about 18.235 ... inches. I could give you the full number, but I don't really care. So now we actually have to calculate her weight, and she drops her weights from her wrist. And so I calculated her head to her wrist, which is 1.5. So the distance between the floor and where she dropped them is 1.9, because 1.9 plus 1.5 is equal to 3.4. So now we multiply 1.9 times the previous value of inches, which is 34 ... inches. So now we know how high it was that she dropped it. So I went to Google and searched it up. In order to shake the floor, you need 63 million newtons of force. Now, I know that this sounds tough to hear, because like where do we go from here? Don't worry, I have this. The ground isn't hollow. I don't think y'all understand that. So for her to shake the ground, it would have to shake the entire city, because again, the ground isn't hollow. So yeah, she shook the entire city. And again, to shake the entire city, 63 million newtons of force. This is actually an underball, because you could say she shook the entire planet, but I'm not gonna say all that. Anyways, to get the force, to get like the equal force to the 63 million newtons, we need to figure out her acceleration. And to get her acceleration of her weights, we need to figure out the speed that they moved at. So I calculated the time from when she takes them off to when the rumbling that you see in game ends, which is 3.37 seconds. I went a little bit over, so we calculate for the average 20 milliseconds human of margin error, and we have 3.17 seconds. So now we divide 34 point excess numbers over 3.17, which gives us a number of 10.2967155 meters per second. Yeah, meters per second. And when we get the acceleration, it is 3. Oh wait, not meters. It's feet per. It's feet per sec. It's inches per second. My bad, guys. My bad. And then we get 3.447845915 inches per second squared for the acceleration. So now to calculate the mass, it is 63 million is equal to m times the previous value, which means that m is equal to 18,272,278.2 kilograms. That is the mass of her rings, if assuming her height is 5.2 inches. Wait, did I say inches? I meant feet. Anyway, sorry. My script is mostly like the math formula, so a lot of what I'm saying is just like off the top of my head. Okay, so now we calculate the mass for the force that they executed, because remember, guys, weight is equal to mass times 9.8. What we just calculated was only the mass of the rings. So like the math is like if you put it on a weight scale, that's what you'd get. The weights is how like heavy it is generally. Like I don't know a better way to differentiate them. Anyways, we do mass times 9.8, which is 179,068,327.1 newtons of weight. And every 1 newton of weight is equal to a kilogram per meter square, per meter per second square. Now, I'd say Sonic's Earth is actually 5 times denser than ours, considering the fact that, I don't know if you know this, but it can tank lasers. Like, look at this shit. Okay, so I'd say it is 5 times our density. But I'd also say it is equal to the radius of our Earth. And that means that it's actually 5 times the gravity, because it needs to be equal radius but denser for the gravity to increase like that. So now we just multiply the previous value by 5 for a number around 895,341,635.4 newtons of weight. Though if you don't like that, you can always keep it like old, the way it was before. Now that we have that done, most of you will say, but Catboy, she isn't 5 foot 2 inches, she's 3 foot 3 inches, or 2 foot 11. And to that I answer, I didn't calculate her when she was 2 foot 11. But I did calculate for assuming she is 3 foot 3 inches. So yeah, I'm tired of talking, so I'm just gonna put all the math on screen, and this will actually also help you guys like understand my thought process on how I got these numbers. So anyways, now that that is done, this is the formula. But we're forgetting something. She usually does, like, she wears these weights when she's relaxed, which, if you don't know, the human body only uses less than 5% of its actual, like, your muscles only use less than 5% of their full power when you're relaxed. And Amy wears these casually, so she's always relaxed, and she's also like practically superhuman. So I'd say she's around 3% when she has them on. So now we just do 100 divided by 3 times answer. Now we just do 100 divided by 3 times answer for a max lifting weight of... Okay, you are right, Ace Attorney. The human body isn't a machine. You actually grow exponentially stronger, not linearly. So that means you at 3% is not just you at 3% is not just 33.3 infinitely repeating divided by your number by your actual full power. The number is actually 2 to the power of 9.7 according to the math that I got from online, which is actually a whopping over 831 times stronger. So you multiply the two, and then you get your max lifting weight of 11,838, 776, 4700 newtons of. Oh shoot! Guys, I kind of forgot something. I actually only calculated for one weight. In Sonic Battles, she says she has 4 weights. So now we multiply these numbers by 4. So weightless Amy is carrying 4.735510588 times 10 to the power of 13, aka 47,355,105,880,000 newtons of force. That is her lifting strength at full strength. I also didn't calculate for the fact that she kind of admits in this game that she has an eating disorder. So like that would actually also nerf her to like 15%, so her number is even higher than that. And I didn't bother calculating for her Pico hammer either, because we all know that, because based on a throwaway line where they said if she accidentally drops it. Now granted, this was a joke in the Sonic Twitter takeover, but I'm just gonna count it because it's the closest thing we have to an actual weight measurement for it. She drops it accidentally, she could theoretically crack the earth like Dark Gaia, which, if you don't know, that is a lot of force, because to destroy a planet from the little distance that she would drop it, which is actually less than an inch, you would need it needs to be able to accelerate to over the speed of light in less than a second, which is ridiculous if I'm being honest. So yeah. Anyways, for her striking force, we get... Okay, but before I calculate her striking force, you need to understand that Sonic characters are faster than light, and we don't know how much faster than light they are. So for that, I'm just gonna put X. So the number is bracket 4.735510588 times 10 to the power of 13 close bracket multiplied by open bracket X being any unknown value, because X is what we're actually here for. The 3.00 times 10 to the power of 8 is just the speed of light. We keep the speed of light there, just so that we know that X is the value we're measuring, but we have the greater than sign so that we know that X is bigger than this. X is higher than the speed of light. And yeah, that is her striking force. If you don't know for short, a punch from Amy is actually enough to destroy the planet. Like a full power, full speed punch from her would be enough to destroy the planet. And keep in mind, this is as of Sonic Battle. Amy is one of the few Sonic characters that actually train. So as of Frontiers, she's significantly stronger than this. And also, fun fact, I did all this math and wrote this script at 11 p.m. to 3 a.m. and I lost a lot of sleep. All in all, Amy is actually a monster. A single punch from her is actually like cosmics. I don't think you understand. Like, not even her hammer, just like a physical punch from her is like messing planets up. And this is as of Sonic Battle, remember. She trains with Knuckles, so she's stronger now than she was back then. All in all, I hate this fucking math. And I don't really know what I'm gonna do now. I'm just gonna dump all this knowledge into the final zone, guys. Anyways, thank you, and see ya.